Welcome to the first class of the Programming for Engineers course. In this presentation, I'll introduce some of the foundations about the work that we'll plan during this semester. So why participating in this class? What would you expect to getting out of this? So this is an introductory class in programming. So generally, it's targeting an audience that, although as an engineer, you are expected to be familiar with a certain degree of formal thinking and algorithmic thinking, there is no real prerequisite in terms of programming, but familiarity with languages like MATLAB or other scripting languages would be useful. General, though, with taking this class, you will become much more comfortable and independent in dealing with the programming languages. And this is meant to potentially help you in your research activities, obviously also in your work in a broader sense. Although the experience is limited, at least you will have enough proficiency to start using external libraries generated by other people. And in general, being able to be familiar with programming techniques. So if you look at a piece of code written by someone else, you will be able to understand the programming techniques that underline that type of work. You will go from the basic creation of small script to understand how dealing with a little bit larger code bases, and in a very specific way become familiar with the concept behind object-oriented programming, which are very important in modern programming activities. So what languages are we gonna use? So although it's just a single semester, we'll work to target two different languages, C++ and Python. This is very important from a pedagogic perspective because those are two, I would say, the two dominant languages today, especially in engineering and scientific computing. Because C++ is really the language that delivers high performance, high speed in computations, and has a lot of the modern concept in advanced object-oriented programming. So it's very important somewhat to be able to write a code, but also to be able to look at the code, understand how it's structured, maybe potentially modify an existing code base. Python has the characteristics, a set of characteristics that are complementary to C++. Is actually not fast per se, but is what people call a language that enable high user productivity. This means that the time it takes to build a functioning prototype for a given problem, it's much shorter. So it's not fast in the sense of CPU time, but it makes you fast in building a solution. So as you can imagine, the combination of those two languages allow to build modern, effective softwares where you use Python for initial prototypes and high-level components, and then for aspects and functionalities that requires high speed, then that could be replaced in C++. So what are the things that you should expect to take away from the class? So generally this class can be important if you want to take more advanced programming courses, and or courses that have a programming component so that you can have a strong basis. In general, it will make you more independent if you have to build some applications to support your research. And generally, if you're preparing for a professional career where programming it's important, this will give you the basis. You can always learn more on your own, but having this foundation will be extremely useful. So there are specific course objectives that will be linked to the way we organize the lectures and the homeworks. In particular, at the end of the class, a student should expect to be familiar with the two main languages, C++ and Python, but also that will give you the ability to even understand easily other languages, given those that are very different from each other and dominant. You will be capable to take an example and extrapolate the structure in terms of object-oriented programming. And more importantly, you can take a piece of software and critique the efficiency and reliability, and in particular find problem areas that need to be solved if you, for example, are using a library written by someone else, but you have to address a problem before you move on. You're not totally in the hands of the external people. Important is the knowledge about C++ data structures, and we will go through enough of those, like vectors and other type of sequences. In Python, being familiar enough that you can quickly locate new libraries and incorporating them in your application. That's in fact one of the main strengths of the Python language, the fact that it has many different libraries that are easy to integrate, and so some practice during this semester will increase your ability to just go out and build solutions that include high performance computing aspects, web processing, and very diverse aspects like that. From the efficiency on the language, understanding when it's important to focus on very efficient data structure and when instead that's not critical, so you want to be more flexible, more high level, and less focus on raw performance, but more productive in the way you write the code. And finally, you will be able to provide a formal description of a problem that can be implemented directly into a piece of software, and that's stem a little bit from your formal background as an engineer, but it needs to be refined and achieve the level of detail that is required to turn a problem description and solution into something low level that a computer can understand. And finally, but not secondary at all, we will do some programming to build a user interface. And that's very important because the way people program a user interface is very different than the typical computing core. It deals with event and user interaction, and so that requires a particular skill, and we will at the end of the semester spend a couple of homeworks, especially in Python and Qt, to make sure that that type of expertise is at least introduced. So during the semester, again, this is an online class, so in addition to using Canvas to access the material, you will be encouraged to communicate with us through the Canvas messaging. Please always send a message to the three of us, so there is an item where you can send individual messages to all the instructor and not just one, and so that will make sure that at any given time at least one of us will quickly pick it up. That's very important. But we will also have direct office hours Monday, Tuesday, Wednesday, and Thursday at 4 p.m. So we will publish probably as a Google document or a Google sheet, a sign-up sheet where people will put their names, and then through Microsoft Teams, and it's a software that is available through the university website, we will contact directly the people through the list. It's very important that you use the university version of Microsoft Teams, and so this is the web address, because we will go through your university ID when contacting, and so we will probably create a group so that there can also be direct messages exchanged and so on, but we're not going to go through other like email addresses and so on. We'll go through the formal university accounts. The course website has already some information. We will have in particular in Canvas all the links to the information, slides, PDFs, some documents that replace potential books, although we are indicating also possible books. None of those are required. And we will, important to use the discussion forums so that any information that we provide to one student is available for everybody. So please try and use as much as possible the discussion forums and resort to direct contact to the three of us for things that are very specific. This is the communication channel outside of the forums that is favorite. So you go to Canvas, choose the course, and remember to send the email to all the teachers, not just one, so that one of us will be able to pick it up and respond to you. So the course structure will be articulated into a sequence of modules that start from the foundations of C++. The early stage may be a little bit boring for some of you if you're already familiar with Visual Studio, but it's very important that we bring everybody up to speed, and so we want to make sure that people that are totally novel do not become completely overwhelmed. After that, then we will become moving forward a little bit faster rate. But so initially will be really just a description of how to use Visual Studio. It's very, very basic programming, just as an illustration of how to write the program, do the compilation and execution and testing. And then for the bulk of the semester, we will be focusing on object-oriented programming in C++, using projects with external libraries, especially the standard libraries. You will see how formally the language has a very limited set of capabilities, but it's also attached to a set of standardized library, the math library, IO library, and so on. And those are, knowing how to use this is important to use the language very quickly without having to re-implement yourself a lot of basic functionalities. So understanding how numbers and math are implemented on a computer, it's an aspect that will focus quite a bit, and then use it with, together with standard templates, processing, and other aspects that are mainstream in the language. We are open to suggestions, so please send us a message if you have interest in particular features. We don't know which requests we may or may not be able to accommodate, and if we do, we might have to adjust the schedule a little bit and maybe de-emphasize other aspects, but I think that will help keeping the course fresh. The later part of the class will be focused on Python and the Qt library. Qt is probably the main library today used for fast develop user interfaces, and in combination with Python, it's really powerful and fast in terms of building an application. And so we will use this at the end for a few projects to make sure everybody is familiar with the process of dealing with events, having user interfaces. And so if your engineering projects require a particular solution, you can have a front end in Python and a back end computation in C++. Of course, throughout, we will learn computer science, data structure in the various projects, and that's really one of the main goals of your learning experience. As I said, syllabus is online, also linked inside Canvas, and actually this might change location depending on updates. The grading is going to be fairly simple. Normally we would have participation in class, but given that we're doing everything online, that component has been eliminated with respect to the past. So there will be a 65% due to the solution of homeworks, and 35% with a few midterms and a final at the end of the course. And those together will form the overall grading. So we don't have a formal textbook. All the notes that we will provide in lecture and so on are sufficient to take the class. We will distribute also a PDF with notes created in a previous version of this class by Professor David Johnson, and they are very good for the needs of this particular class. There is a number of textbooks that can also be very useful. There is a number of online resources. Generally, for programming languages, especially C++, and even more for Python, there is really a lot of material. So a lot of tutorials. Python in particular is well known to have a lot of documentation, and given that the speed of the change of documentation, it's best if people are familiar with accessing information online. So this seems to be obvious, and I'll phrase it not as a threat but as a pleading for a favor. Obviously, cheating is not allowed. I want to just highlight that it's very easy to catch cheating. It's really not worth doing it. I've been a student myself, so I know the temptation, but really it's much better to submit a half-finished homework. We'll do everything we can to give partial credit to an honest homework. There are online tools. This is one of the tools that we will use. It's called MOS from Stanford University. This is an extremely good tool. This is being used even in legal cases in court to catch plagiarism and so on. So please don't have the illusion that you can beat the system. Please don't tell me that since the problem is simple, two solutions can be identical. It is not like that. When two people type even the same solution out of memory, a few hour distance, they will not look identical. So please write your solution alone. Don't write your solution while you're communicating with someone else. If you talk to someone about high-level strategy to solve a problem, wait a few hours, and then solve it alone independently. That will avoid falling in the trap of being caught from cheating. That's unpleasant for everyone. Just please don't do it. Uh, um, and now, after this difficult note, I wish everybody a great semester. I hope this will be a great learning experience. And again, give us feedback about things we can improve, the things that we're not doing you would like to learn, and we will do all we can to improve the material and update it even outside of the things that we're planning to do. And thank you very much.